In a world powered by machines driven by innovation and filled with unbelievable facts, this is not just a channel. This is All Facts in One, your ultimate destination for amazing facts and powerful technology. Subscribe now and explore.
Today's explainer class, we're diving into an absolutely fascinating piece of industrial history today. We're going to look at how a wildly loud, explosive piece of 1878 engineering completely democratized global personal transport and revolutionized industrial design as we know it. We're talking, of course, about the legendary two-stroke engine. Let's run right through our syllabus for today. First, the 1878 engineering breakthrough. Then we'll hit the mechanics of the two-stroke, move into how it democratized global personal transport, compare racing versus agricultural applications, discuss the environmental emission crisis, and finally, look at its modern performance engine revival.
All right, Section 1, the 1878 engineering breakthrough. To really appreciate the genius of this engine, we have to understand the massive hurdles engineers were dealing with during the height of the Industrial Revolution.
Think about early steam and four-stroke engines for a second. They were absolute mechanical behemoths. I mean, we're talking massive, incredibly heavy, painfully slow, and packed with these complex valve trains that made them horribly expensive to produce. Inventors desperately needed something more accessible. Enter Scottish engineer Dougal Clark. He essentially looked at all that complexity and stripped it away, introducing a design that was radically compact, super lightweight, had virtually no moving valve train parts, and was remarkably cheap to manufacture. It was a total game changer.
So 1878, that is the year that officially marks this breakthrough. That's when Clark successfully built an engine that could complete its entire power cycle in a fraction of the time of its predecessors. By basically doubling the firing frequency compared to a standard four-stroke, he created a complete paradigm shift in mechanical design and power delivery.
Moving on to Section 2, Mechanics of the Two-Stroke. What's so fascinating here is the pure mechanical genius behind that unprecedented speed and efficiency. Let's look inside the cylinder.
So unlike a four-stroke, this engine gets the whole job done in just two swift piston movements, using something called crankcase compression. Step 1 is the compression stroke. As the piston moves upward, it compresses the fuel and air mixture in the cylinder, creating a vacuum that simultaneously sucks fresh fuel into the crankcase right below it. Then step 2, the power stroke. A spark ignites that compressed mixture and boom, the explosion forces the piston down. As it drops, it pushes exhaust gases out while simultaneously forcing that new fuel mixture up through transfer ports to start the whole cycle over again.
And here's the absolute kicker. Because of those two simple strokes, power is produced on every single revolution of the crankshaft, every single one. A standard four-stroke, on the other hand, only produces power on every second rotation. This single mechanical reality is exactly what gives the two-stroke its legendary power-to-weight ratio and that aggressive instant acceleration that just completely outclasses heavier engines of the exact same displacement.
Section 3, democratizing global personal transport. Now, as engineers, we know that when you drastically improve power-to-weight ratios and slash manufacturing costs, you don't just change the machines themselves, you literally change global society. By the early to mid-1900s, this affordable technology sparked a massive global post-war economic boom. Nations that were rebuilding their economies, like Japan, Germany, Italy, the UK, they fully embraced this lightweight engine. Why? Because it democratized mobility for the working class who simply couldn't afford full-size cars. This accessible utility gave rise to legendary manufacturing brands we all know, like Yamaha, Suzuki, Kawasaki, Vespa, and Jawa. A cheap, small two-stroke engine meant practically anyone could afford to ride to work, which directly helped jumpstart local economies all over the world. But it wasn't just a socioeconomic shift. It became a completely visceral, cultural phenomenon. The sound of a two-stroke engine became unforgettable. You know the sound. That loud, explosive, screaming signature completely defined a global generation of mobility, youth, and post-war freedom.
Section 4. Racing versus agricultural applications. The sheer mechanical simplicity of this engine allowed it to aggressively dominate two completely different global markets at the exact same time.
Think about the incredible versatility here. On the track, the exact same base mechanics were tuned for ultra-high RPM dominance using specialized expansion chambers and finely tuned exhausts. These lightweight two-stroke bikes were literally defeating much larger, heavier four-stroke competitors. No contest. Yet far away from the racetrack, that same core engine was powering the global agricultural and utility sectors. Think chainsaws, outboard motors, lawn equipment. Because a two-stroke lacks a complex oil sump system, a logger could hold a chainsaw perfectly sideways or literally upside down without starving the engine of oil. It became the ultimate unkillable hard labor tool.
So, it defeated heavyweights on the track, it powered hard outdoor labor across the globe, and it mobilized the post-war middle class. We have to ask the obvious question. How could a mechanical design this versatile and brilliant suddenly face global extinction?
Which brings us to Section 5, the environmental emission crisis. As is so often the case in engineering, a machine's absolute greatest strength can eventually become its fatal flaw. The very design that made it so lightweight and powerful ended up creating a massive environmental crisis.
If we track it, we see the 1878 initial invention, the mid-century global transport boom, and its crazy track racing dominance through the 70s and 80s. But then, the two-stroke hit a brick wall. In the late 1990s and early 2000s, this golden age crashed headfirst into the modern era of environmental consciousness. Governments worldwide started passing incredibly strict emission regulations, specifically targeting small engine pollution.
Let's look at the technical reality of that emission flaw. Because the two-stroke lacks a dedicated oil sump, oil has to be mixed directly into the fuel just to lubricate the crankcase. This total loss lubrication system means the engine is inherently burning raw oil right alongside its gasoline. The result? Thick smoke, terrible fuel efficiency, and a massive amount of unburnt hydrocarbons and highly harmful environmental pollutants. Regulators simply couldn't ignore it anymore, which forced manufacturers to pivot back to cleaner, albeit much heavier four-stroke technology for everyday roads.
But wait! Section 6, Modern Performance Engine Revival. Modern engineers are famously stubborn, and they were definitely not ready to let this legendary power-to-weight ratio just disappear completely into the history books. By introducing some truly advanced comeback technologies, the two-stroke actually made a high-tech return. Engineers started applying highly precise direct fuel injection, perfectly calibrated electronic fuel systems, and optimized much cleaner combustion methods. By relying on computers to deliver exactly the right amount of fuel and oil at exactly the right millisecond, they drastically slashed those harmful emissions while entirely preserving the engine's aggressive, lightweight power.
And thanks to these clever mechanical fixes, the explosive spirit of the two-stroke didn't die out. It's actually still thriving today in specialized sectors where power to weight is absolutely paramount. We're talking high-performance motocross racing, advanced marine outboards, and heavy-duty industrial applications.
As we wrap up today's explainer, I want to leave you with a final, provocative thought about the future of mechanical design and environmental compromise. Will continuous improvements in clean combustion guarantee a permanent place for the two-stroke? Or, at the end of the day, is it destined to be remembered only as the loud, explosive relic that once democratized modern transport? It's definitely something for you engineers to think about as you go out and design the machines of tomorrow.